Hello students, today we will discuss about the continuation of trends in technology, and here we will focus on the various aspect of power and energy, which is the major concern regarding the functioning of various devices, circuits and devices present in the computer system. So we will look at power and energy as a in a systems perspective. What is a power? What is energy? As the name indicates, power is related to the current that we are actually given, the power supply that is given for various elements present in the computer system. As we know, we are having a power supply, switch mode power supply available for a desktop PC, which is actually giving power supply to all the elements. We know, if you know the internal, if you have seen that internal components of computer system, it is power supply is connected to all the elements. Even for the working of an IC, every pins, all these are actually connected to some power supply. So power is an important factor for the working of any of the devices present in a computer system. And similarly, energy is actually related with power, but we can consider energy when the power is connected to, or it is specifically related with a task. If it is related with a particular task, it is called as energy. The total power requirement, or the requirement for the functioning of that particular task, is actually the energy. So actually power and energy are both related, and they are actually functioning together along with the total power, distribution of power, the energy requirement for different tasks, different devices present in a particular system. So when we consider these power and energy, we need to consider 4 different factors. We are actually raising 4 different questions. One is, what is the maximum power a processor ever requires? So what is the maximum power a processor ever requires? So whether there is any limit for a processor, for an IC processor, because when we buy a device, we can see that the maximum voltage that can be accommodated by a particular device. So maximum voltage will be given. So if you use a mobile charger, what is the maximum voltage that can be acceptable by that particular device? So similarly, whether there is any such limit, or whether there is any maximum power limit for a processor for the execution. If it is there, what is that? If it is not there, what can be done? So we will discuss that in the next slides. Similarly, the second question is, what is the sustained power consumption? If more power is being consumed by a particular device, a particular IC or any other device, so what is what about the extra energy that is being produced by the additional power that is being consumed by the device? What can be done? Whether there is any provision for that, whether something extra to be done for removing that. So that is the second question that is being raised. And next point is about what is an energy and what is energy efficiency, how it is being related. What is energy and what is energy efficiency? Energy, how a system, a device can utilize the energy in an efficient way, and how we can define an energy efficiency. And finally, when is power consumption a useful measure? So when we use various devices, chips inside a machine, every devices are consuming the power. Now sometimes for some evaluation, we need to consider the power consumption. So which is the major situation, or in what situation, in which type of machines the power consumption is a useful measure for deciding the the advantage or feature of that particular machine. So these 4 points are actually being mentioned or being proposed in a systems perspective for a general consideration of power and energy. So first question, we'll see some details. What is the maximum power a processor ever requires? So if a processor attempts to draw more power, so suppose if a processor attempts to draw more power than a power supply system can provide, the result is a voltage drop. Okay, so we should have a provision. So when a designer is trying to design a new computer system, he should consider about power supply. So normally there will be a limit for the power supply that can be given to a processor. But if the processor tries to draw more power than the power supply that is being connected, sometimes that may also happen because it is a hardware device. Sometimes we cannot even the voltage limit is given, sometimes it may vary. So if it draws more power, what is to be done? The problem that is happening is a voltage drop, so that will affect the system. The device will be functioning or it will be doing malfunction. It won't be working properly. So the designer should consider about a solution for that by adding a voltage indexing method. So we should have a solution for that. So we are setting a power limit. What is the maximum power supply limit? We are setting that even after that, if it is consuming some more power, that is to be that is to be protected by using a method. Otherwise, the system will go to function in a different way. So that will affect our system. So we should have a voltage indexing method. So what is voltage indexing method? It allows the processor to slow down, and it will allow the processor to slow down and regulate the voltage within a wider margin. So the performance may be decreased. So if it goes above a particular voltage level, whatever things are working on that particular system, it should be, means the processor, it will be working in a particular speed, so that must be slowed down. Processor will be slowed down, and the voltage will be regulated, and gradually it will be reduced. So then again it can increase the speed. That is why sometimes when our system gets more heat and all, sometimes we can see that our system performance will become, it will be affected. So that is because of the slowdown of the processor due to the over power consumption. So we should have a provision. So this question, for having these type of problems, we should have an voltage indexing method mechanism where we can manage automatically. The system should slow down to control the system. Otherwise it will affect the entire system by doing some malfunction. So in order to avoid that, we should have a voltage indexing method. Now, what is a sustained power consumption? It is related to the first question only. The sustained power, the over power that is being sustained by the system, which is usually called as thermal design power. Thermal design power, the additional power it consumes. It determines the cooling requirement for the computer system. If it receives more power, means from the power supply, it is receiving the power, and if it is consuming more power than it is required, it should have some provision for, because automatically that additional power will generate some heat. So heat will be dissipated. So we need to avoid that heat. For that purpose, we are using a different mechanism based on the thermal design power. So thermal design power is a cutoff from where we need to have some additional feature to be added. So a typical power supply for a system is usually sized to exceed the TDP. So it can exceed the thermal design power, and after exceeding that, automatically a cooling system must be available. So the cooling system is the solution for the sustained power consumption that is present in a computer system. So every computer, desktop, PC, laptop, all the devices will be having an internal fan, which is a cooling system that is just for avoiding the additional sustained power being consumed by the device. So it can actually exceed the thermal design power, but after exceeding that, automatically sometimes we can see that sometimes fan will be working, sometimes fan will be off, it will be switching off. So automatically according to that cutoff, or based on that cutoff TDP value, the cooling system must be active, and accordingly we can control that additional consumption of power. Now if we fail to provide such cooling, the temperature will exceed to a maximum value, will resulting in the failure of the device. That is always clear. If the fan is not properly working for our laptop, you can imagine automatically your system will become it will create some problem to your system. So there are two features to assist or managing the heat. As the temperature approaches the junction temperature limit, that is the TDP, circuitry reduces the clock rate, thereby reducing the power. So there are two more solutions to assist that overheat that is being generated even after the cooling system. So what is happening, as the temperature approaches the junction temperature limit, circuitry should automatically reduces the clock rate. So automatically, so clock rate actually decides the speed of the system, the performance of the system. Automatically it will reduce the clock rate. Clock rate will reduce means performance, the speed will be reduced. So when the speed will be reduced, then the power requirement or the power will also be reduced according to the clock rate reduction. Okay, so similarly another mechanism is a thermal overload trip is activated to power down the chip. So sometimes we are having another solution, like if the temperature reaches more than some particular point, automatically like our system, means our power supply in our home, if it goes into means some overload under, automatically it will trip. Okay, our system will be like that, the current system is like that only. Similarly the computer system must also have a mechanism for an overload trip. It must be activated to power down the chip. So what is happening if it is being tripped? So the functionality will be stopped. So that is an issue. So if it is a slight temperature, the cooling mechanism can be utilized. But if it is if it cannot be controlled with that cooling system, if it reaches a temperature limit, one solution is to reduce the clock rate, so that performance will be decreased but the system will be working. But another solution is you need to have a trip to shut down the chip. But the problem is it will not affect the system, but it will affect the currently running program, currently running process. So but even it can save the system by having a overload trip mechanism in order to avoid or solve the sustained power that is being consumed by the computer system. So this is the solution for overcoming the second question, that is what we can do with the overly consumed power within our system. Now next one is energy and energy efficiency. So what is energy and what is energy efficiency? So we were mentioning about power, which is equal to energy per unit time. Power is actually equal to energy per time. Energy per time is actually power. So whatever power it is being acquired will be utilized as energy. So there will be number of tasks that is being performed simultaneously, and each task will be taking its own energy, to be utilizing energy based on the power being acquired. So different energies will be created, means energy will be utilized by different devices, different tasks. So so the total energy that is being utilized per unit time can be considered as the power requirement for that particular system. So energy is usually used as a better metric to compare processors, the energy consumption of a particular processor, because it is tied to a specific task. and the time required for the task. So energy power is actually not specified, or which is not tied to a particular task. It is the general thing. Power supply is given to all the devices, all the tasks, all the chips and all, but energy can be considered as a better measure for comparison of different processes, because it is tied to a particular, or it is tied to a specific task. Then energy to execute a workload is equal to the average power times the execution time for the workload. Energy to execute a workload is equal to, so energy for a particular workload is equal to the average power times the execution time for the workload. So the average time taken for the completion of that particular average time for the entire workload, that is the energy for a particular workload. That is the mathematical calculation for that. We will see little more detail. Now we will have a comparison, energy and energy efficiency. Based on the previous formula, we will have this. So assume that we are having two processes A and B. Assume that we are having two processes A and B. One is A and second one is B. Two processes. We are simply going to have a comparison between two processes A and B. So A has 20% higher average power consumption than B. So A is consuming 20%. So B is the benchmark. I am considering B as the benchmark. A has 20% higher average power consumption than B. So assume that B is having 100%. I am taking it as 1 power consumption, and A is having 20% higher power consumption, that I can consider as 1.2. So if it is 100, it is 20% higher, means 1.2. Okay, for A. So power consumption of B is only 1, but power consumption of A is 1.2. Now similarly, we'll consider one more thing, because we are considering energy for a specific task. Energy is related to a specific or a particular task. So A executes the task in only 70% of the time needed by B. A executes the task in only 70% of time. So A executes a task in 0.7 times than the time needed by B. B need 100% time. It requires only 0.7, 70% of time than this one. So B power consumption is 100%. B task time is also 1. Okay, so just for a comparison, we are taking two constraints. One is the power consumption. Here it is 1, here it is 1.2. It is consuming more power, it is consuming less power. Now the time taken for a task by B is 1, but for the same task A takes only 0.7. For example, we are considering these 2 points of two different processes. Now the total energy consumption is for the system A, that is 1.2 into 0.7. Okay, power times power into time, that is the energy consumption, power into time of a particular task. Okay, so 1.2 into 0.7, that is actually 0.84. 0.84 is the energy consumption of A. 0.84 is the energy consumption of the processor A. What would be B energy consumption is 1. Now just have a comparison. A is having 1.2 power consumption, B is only 1. A is having 0.7 time for a particular task, B utilize time 1. Now power in time based on a particular task, we are taking that particular task. 0.84 is the energy consumption for the task by using processor A. but one is the energy consumption for the same task done by using the processor B. By looking at these two values, we can see that 0.84 is smaller than 1. So we can say that A is energy efficient than B. Okay, so we are not only considering the power consumption, we are also considering the time taken for completing the task. So these two will decide the power consumption, and the time taken for a particular task will decide the energy efficiency of a particular processor. So that is what it was given in the previous slide. Energy to execute a workload is equal to the average power times the execution time for the workload. So it is related to the power and execution time for a particular workload. So I hope it is clear. Just it is not like a problem and all. It is just a comparison between two processes. It may vary, depends on the power consumption or the time taken for completing the task. So sometimes the power consumption is more, the time taken for completing the task is also more. So that situation automatically the energy efficiency will also vary. So sometimes the time taken will be more, the power consumption will be less. So that time energy efficiency will be better. Okay, so in that way we are evaluating the energy efficiency of a particular system. It depends on both power consumption and the time for completing a particular task. So energy is always related to the, it is tied to a particular task. So next point is, when is power consumption a useful measure? The last point is, when is power consumption a useful measure? So when we evaluate the various computer system, the processor, performance, comparison and all, at what situation the power consumption can be considered as a better measure for evaluation. So now for this explanation, a chip might be limited to 100 watts. The total power requirement for a particular chip might be limited to 100 watts. So it can be used as a metric if the workload is fixed. If the workload is always fixed, so the point is, if the workload is, so a chip can maximum consume 100 watts, and for 100 watts, if the workload is fixed for means we cannot say that dynamically if the workload is being increased, that cannot be permitted. In that situation, if the workload is fixed, the power consumption can be considered as a useful measure for evaluating different processors. So it is just a variation of the true metric of energy per task. It is just a variation of the true metric of energy per task. So as I was mentioning in the previous slide, energy is always depending on the, or it is always tied to a particular task. Now if the task number of workload is fixed, we can consider the power consumption as a better measure for the evaluation of two different processes. So the question is, when is power consumption a useful measure? When the workload is fixed. So that is all about the four different questions related with the power and energy in a system perspective for comparison of different processes that are used within a computer system. So we will see some more details regarding energy and power in relation with the processor in our coming slides. Thank you.